2.2 objectives. Yesterday we talked about identifying intervals on which a function increases, decreases, or is constant. We talked about using graphs to locate relative minima or maxima, and we talked about different tests for symmetry. So today we need to talk about identifying even or odd functions. We need to talk about understanding and using piecewise functions, and we need to find and simplify a function's difference quotient. Okay? So even and odd functions. Let me give you the definition of an even function. Okay? A function. Whoa. Okay, there we go. A function is even if f of negative x equals f of x. Okay? A function is even if f of negative x equals f of x. For instance, let's talk about the parent function for quadratic. Okay? To decide if this is an even function or not, anywhere there's an x, I'm going to put in a negative x. Okay? So I'm going to say f of negative x. Anywhere there's an x, I put in a negative x. Well, what is negative x squared? Isn't that x squared? So f of negative x equals x squared. That's simplified from the original when we substituted it originally. So if these two are equal, then it is an even function. Does that make sense? Okay. The other thing that you need to know is that the graph of an even function, is symmetric. Whoa, SY. To the y-axis. So thinking about what a quadratic parent function looks like, is that symmetric to the y-axis? If I cut it or folded it on the y-axis and folded it up this way, would it be right on top of each other? Yes. So do you see why we had to talk about testing for symmetry first before we could talk about even and odd functions? We just had to remember that, okay? So a function is even if anytime you substitute a negative x for x, you get the same answer, okay? That's how you know a function is even, by looking at the function. How do you know? By looking at the graph if it's an even function. If it's symmetric to the y-axis. Okay? So the other function that we have to know is odd function. Okay? A function is odd if f of negative x equals negative f of x. Oops. F of negative x equals negative f of x. F of x equals x to the third. So I want to try this, f of negative x. What's going to happen if I put in a negative everywhere there's an x? Negative x to the third is going to end up being what? Negative x to the third, like that, right? Okay, so is this answer, is the value of the function the negative of that one? Is it the opposite of that one? It is, so that is an odd function. Okay, Does that make sense? The graph symmetric with respect to the origin. It's symmetric to the origin. Think about what a cube root parent function looks like. You see how that's symmetric to the origin? No? Like take this part right here and like it's kind of like we spun it around. Yeah, I guess we can fold it kind of twice. Yeah. 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 Okay. So, tell me, do you think you can tell if a function is even or odd just by looking at the graph? Even or odd? Even. Why? It's symmetric with respect to the y-axis, right? Okay. Odd because it's the origin, right? Okay. It is a function, but is it even or odd? Neither. Okay. I can't fold it up on the y-axis and have it be on top of itself. And if I spun it around, it wouldn't. There's nothing over here for it to be. So it's not either even or odd. So that's kind of a big deal because I need you to know that there is such things as not even or odd. Just because something's not odd doesn't automatically make it even. Right? If we try it and we find out that it's not even, that doesn't automatically make it odd. Okay? It could be even, odd, or neither. That was something that I really had to work on when I was in topology, one of my graduate level classes, because you can have an open set and a closed set, but when you do the test and you find out it's not open, that doesn't mean it's closed. I kept trying to compare it to a door. A door is either open or closed, period, right? It's not like that at all. It's a set of numbers that can be an open set of numbers, or it can be a closed set of numbers, or it can be neither one. And that was just always like, just like mind-blowing for me. Yes, sir. I don't think it's either. Yeah. Because you have to know what the last number is, and we don't. Yeah. Uh-oh. I don't think that's even or odd either. No. I would just run away. I would just run away if I had to bet my entire life savings. Okay. How are you feeling about even or odd functions? Okay. Look at these real fast. I'm going to cover up the answers this time. How about that? Even or odd? Even, because you can fold it on the y-axis. Even or odd? Neither. Even or odd? Odd. Look. Even, neither, odd. Yes, we are. Okay. How do you tell if an equation is even or odd? Well, either one we did, we put in a negative x, right? If it's even, it's going to be exactly the same as what we started with. If it's odd, then the whole function is the opposite sign as it was before. Is it possible to be neither? Yeah, it is. Okay. Even when we put in a negative x into the actual function, we can get something that is neither, neither, even, or odd. Okay. It doesn't have to be even or odd. It can be neither or neither, whichever you prefer. Okay. Okay. Next is understand and use piecewise functions. Now, that verb is pretty presumptuous. Okay. How about if we just I'll just introduce you to piecewise functions. Okay, if you've had pre-cal, you've seen piecewise functions, but if you've not had pre-cal, you haven't seen piecewise functions before. We looked at them like maybe for half a second in Algebra 2, and that was all. Okay, we did look at them. I know we did, because you'll see why in a second. You'll see why they look a little bit familiar. Okay, but it was not something we focused on at all. Okay. Piecewise functions are really, there's a piecewise functions in Mr. Gaddy's. There's a piecewise function in Mr. Gaddy's. Okay? Because if you are 0 to 3, you pay one price. And if you're 4 to 7, you pay another price. And then if you're like 8 to 13 or something, you pay another price. You know what I'm talking about? And then if you're 13 to like 70 or 65 or something, you pay one price, and then it goes back down again when you're over that. You know what I'm talking about? That's a piecewise function. All right. So it's like this. I don't remember exactly what it is. I guess I could have looked it up before I came, but I did not. So we'll just make some guesses. Okay. So if you're age 0 to 2, how much do you think they pay at Mr. Gaddy's? Free. Okay. Free. So if you are age 3 to, 6? We'll just pretend that it's 6, okay? This is pretend Mr. Gaddy's. So if you're 3 to 6, how much do you think they pay?
About $3.
So we'll do $2.99, because that's how food companies make all their millions of dollars. Okay. What about age 7? Whoa, what is that? Sorry about that, 7. 7 to 13, what do they pay? 7? $6.99, okay. And then ages 14 to, like 60? Is it like $9.99? Okay. But then when you're over, I think this is actually 59, because once they get to 60, yeah, and I think it just says 60 and up. Yeah, or 60 plus. That works also. I think they pay like $7.99. Okay. So this is a piecewise function. We could graph this. Okay. So along the x-axis, we're going to put age. And along the y-axis, we're going to put price, right? So obviously this is not going to be to scale, because I need it to be like at least a 60. 1, 2, 3, 4, 5, 6-ish. Okay. So that's 10. Okay. Let me get a purple marker. That'll be 5. Like that. That will just help us a little bit. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and so on. You okay with that? 1, 2, 3, 4, 5. Okay. So from 0 to 2, they're free. They don't pay anything. Okay. So from 0 to 2, including 2, pays $0. $0. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's pretty close. So from 3 to 6, you pay almost $3, right? But this has to be an open circle here. Because if they're, oh, excuse me, that's a closed circle on 3. Well, so what happens if they're like 2.5? That's still 2? Okay, so then this line down here actually goes to 3 with an open circle on 3. Does that make sense? Because all the way up until age 3, they're paying $0. But then once they get to age 3, they pay $3. All the way until they're 6, or what? 3, 4, 5, 6, 7. Really? Isn't it 7? Because between 6 and 7, there's still 6. But once they turn 7, that's I almost said $7. It's clearly not. It's only $6.99. Okay? 1, 2, 3, 4, 5, 6, and a little bit higher than that. So at age 7, they're paying $7. I mean $6.99. All the way until they're age 13, but really 14, right? But not including 14, because 14 they pay $10. And they pay that all the way till 60. 1, 2, so 10, 20, 30, 40, 50, 60. Oh, I made it nice and easy. Like that, right? And then what happens at 60? $8. So it's like down here. Yeah, excuse me, $7.99. And that goes all the way until, well, I don't want to talk about until. So that's what the graph would look like. All right? So we could write this as a piecewise function. Right now it's just a list of ages and prices, right? Okay? So we're saying the function, we'll call it cost. Are you okay with that? So the cost, we'll say C of x. Well, the cost is going to be how much? 0 for when? Between 0 and what? And 3, right? But not including 3. All the way through 2 up to 3, but not including 3. Are you okay with that? Then what happens? What's the cost? $2.99 from where? 3 all the way to where? 7, but not including 7. So we just have less than. Okay? Then it jumps to $6.99 everywhere from 7 all the way to 14, but not including 14, because 14 starts the $9.99. From 14 to 60, right? All the way to 60, not including 60 though, because 60 is the $7.99. And then this is just greater than or equal to x, so I could have written it like this. Excuse me. Greater than or equal to x. Except it's 60. Come on. This is how we see it more often than that. I was just kind of starting to write it in the same pattern. Okay? So this is what the piecewise function looks like. This is what the graph looks like from this data. Does that make sense? So why is it called a piecewise function? Yeah, it's pieces and parts of different functions put together. Yeah. And if it's not, it's a really good, like, made-up answer, right? So it's, to be technical, Carson, to answer your question, a function that is defined by 2 or more equations over a specified domain is called a piecewise function. Okay? We clearly have 2 or more functions here, and specified domains out here to the side. Okay? Now, I could either give you the function, or I could give you the graph and ask you to evaluate piecewise function. So tell me, please, what is f of 4? And you can either look at the equation or at the graph. Well, where does 4 lie in the domain? Right here. It's in between 3 and 7, isn't it? So f of 4 is $2.99. Well, what's f of 5? Wait, except f of 4 is 299. So can f of 5 also be 299? Yeah, as long as it lies in the same domain, it's still 299. Okay? So what about f of 7? It seems like it's there twice, because there's a 7 right there and there's a 7 right there. Is it in this domain? No, it's not. We don't have an equal sign there, do we? On purpose. Okay, so that is 699. Do you understand how to evaluate piecewise functions? Okay. Graphing piecewise functions, we kind of went through that. Now, they're not always going to be horizontal lines, just so you know. Okay? They really aren't. Sometimes they're going to be diagonal lines. Sometimes part of it's going to be a parabola. Sometimes it just really depends. This is the example I chose because I thought it was interesting, because sometimes we go to Mr. Gaddy's after we go to marching contest. Okay? Even though I think CC's is better, just for the record. Okay? But it's a place that you go. I want you to see math the next time you go into Mr. Gaddy's, besides the number of tickets you can win. Okay? I want you to notice the piecewise function that's there. Okay? So how do you feel about graphing a piecewise function or evaluating piecewise functions? You okay with that? Okay. I don't know what that means, but I'll say okay. The last thing you have to be able to do for this section is find and simplify a function's difference quotient. Okay? Find and simplify a function's difference quotient. So you need to know what a difference quotient is first of all. Okay? The difference quotient looks like this. So, does the title of this make sense? Difference quotient? Difference because there's subtraction. Quotient because there's division. You okay with that? Okay, so here's what happens. I say f of x equals 2x minus 3. I want you to find the difference quotient for that function. That means anywhere there's an x, for this part, what do I need to write instead? I just need to write x plus h, anywhere there's an x. Okay? So for this part right here, I'm gonna do them all separately, and then we'll put them together if that's okay with you. Even if it's not, that's what I'm doing. Okay? So if f of x equals 2x minus 3, f of x plus h is going to be 2 times x plus h minus 3. Does that make sense? Anywhere there's an x, I want to put in x plus h. So if I simplify that, I get 2x plus 2h minus 3. Can I combine any of that? No. Okay. Well, f of x is pretty obvious. We already have that. And h seems pretty obvious because we're not doing anything with it, right? So if I say this, what we just found, 2x plus 2h minus 3 minus this thing, 2x minus 3, I need to divide that all by h. Well, what happens right here? I'm subtracting this whole thing, so I'm distributing that negative sign, aren't I? Or thinking of negative 1. So I have 2x plus 2h minus 3 minus 2x plus 3 over h. Excuse me. So what happens? Well, that's nice. Well, that's nice. So I get 2h over h. That simplifies to 1, doesn't it? 2. Now, do they get harder than that? Oh yeah, they absolutely do. Okay, but think of it this way: whatever's here, start by rewriting it by putting an x plus h anywhere there's an x. That's the first part. Then you have to subtract what you originally started with and then divide it by h. Now, the only thing I forgot to tell you about this is we need to talk about h real quick. There's something h is not allowed to be. Can you tell me what it is? It can be a negative. 0. H can't be 0. Okay, that's just kind of an aside, just making sure you realize h can't be 0. Okay, but that's finding the difference quotient. This is one of those things I would love to sit and do all sorts of different quotients with you because I could really amaze you with how smart I am. Because it's fun. Because there's a shortcut to this, but we don't know it yet. You don't learn it until calculus. Okay, it's actually what they were learning like 2 days ago in calculus. But being able to find the difference quotient is an important skill. And we need to know how to do it for this section. Okay? How do you feel about these objectives that we've talked about both yesterday and today? Are you feeling okay about these? At least better than you did before? That's a good start. Any questions?